are still reviewing climate factors. We want to remember that climate is what's happening outside. It's when a scientist measures what happens outside for a long period of time. So what we're going to be discussing today are another two factors that can affect or change our climate. So we need to open our notes, please. If we would please open our notes. And the first factor that we're going to talk about today is elevation. These are old notes that you should have already had drawn, but if not, remember this lesson is being recorded today so that you're able to watch this and draw this picture because you'll need it. When you look here closely at this picture, I tried to zoom it in for you. When you look closely at this picture, someone turn on their mic and let me know, what do you notice about the temperature here?
That is going higher, is increasing.
The temperature is increasing as I go up the mountain or down the mountain?
Up.
Yeah, nope, lower. So
Down.
as I go up the mountain, it's talking about the meters high. So 1,000 meters, 2,000 meters, 3,000 meters. But look at the temperature in degrees Celsius. At the ground, it's 30 degrees Celsius. And at the top of the mountain, it's 10.5 degrees Celsius. So that tells us some things. The higher I go up that mountain, the lower my temperature will become. Before we can talk about elevation of a landform, there's some words we need to understand. The first question we want to have in our notes is, what is elevation? What is elevation? Go ahead and take some time to write that question down. And if you started sketching this picture, that's a great idea. I'm going to show you where you can find this picture in your Schoology folder today. So when we talk about elevation, it's important for us to understand that elevation is the height of a landform. There we go. The height of a landform from the ground. So, for example, here, if I had a picture of a mountain and a hill, someone turn on their mic and let us know which landform will have a higher elevation.
Mountain.
Mountain. Yeah, that mountain's going to have the higher elevation. You can draw that doodle if you'd like. You don't have to. And I keep using this word. I keep using the word landform. So our second question is going to be, what is a landform? I'm going to actually write it down here so you can see it. And I'll write it in a different color. What is a landform? You want to make sure you're taking your notes today, guys. You'll need them. So we want to make sure we know that a landform is a natural structure in nature. A natural structure in nature. When I say natural, that means it's not man-made, okay? So some examples of a landform would be a mountain. It would be a hill. It would be a plateau. All of those are examples of natural structures, okay, natural buildings in nature. Take some time, please, to write both of these questions down and their definitions. Then you want to go ahead and start sketching this picture. I promise you'll need it. Okay? And Miss Neville's going on in 2 minutes. another minute to finish writing this down. Remember, this lesson is being recorded. Okay, so let's go on. We're going to now start moving into what's happening in the world. Our learning objective for today is going to be I is you, I can construct an explanation that illustrates how the law of convection influences or changes wind and water on Earth. So if you would please take some time to write in your notes. These are new notes today. Global winds and waters. Miss Neville's going on at 8:23. You do not need to write the learning objective. You want to make sure you know it, though, as a target in your mind for what you need to be able to do today. So let's keep it moving. Today we're going to be talking about, we have to make sure we remember that law of convection. It's right there in our learning objective. You don't have to draw this. I just want this to be a review for you. So we want to make sure we remember that the law of convection basically explains how heat circulates. So let's talk today about the law of convection. Remind ourselves. Remember, the law of convection states heat will always rise and cold will always sink. Can someone turn on their mic and tell me why? Why does heat always rise? Why does cold always sink?
That's because the hotter air is lighter than the cooler air.
Very good. So I could say lighter, or the word that you're going to be using in 7th grade science is dense. Cold fluids are more dense than warm fluids. And when we're talking about fluids, it's important for us to understand that this law of convection heats fluids. And fluids, you might want to write that star statement down. Fluids are gases and liquids. Yes, wind, which is a gas, and liquids, which is our ocean water. Convection heats gases and fluids. Oops, sorry. And we want to remember, I want to make sure I spotlight this word because you'll hear it a lot today. We want to make sure we understand that this is showing us the circulation of hot and cold. The circulation of hot and cold. When we look at that word circulation, it starts off like the word circle. Yeah. So it's telling us the shape or the direction in which heat rises and cold sinks. So let's look at it. We're now going to look at ocean currents. Did you remember that movie Finding Nemo, where Marlin was looking for his son and he had to take a ride with those turtles, the sea turtles, on the East Australian current? Remember how fast that water was moving? It was almost like that band of water was moving faster than all of the water that was around it. Yes, that was a current. And we need to understand that ocean currents are moved by their temperature. Yes, different temperatures of water move at different speeds. We need to understand, and you're going to be drawing this picture in your notes. The guided notes are already in your orange Schoology folder, and this lesson is being recorded. It's important for you to understand here that the Gulf Stream current is the current that we live on the East Coast. South Carolina is right about here, that we enjoy. The Gulf Stream current carries warm water from that tropical region where the equator is to higher latitudes where the water would usually be cooler. Okay. On the western coast where California is, it carries cold water down. This is called the California current. Yes, this is a cold current of water that flows down from the polar region. So here you're able to see heat rising and cold sinking. In our notes, let's write this down. Question: why are ocean currents so important? The answer here is because these temperatures, the circulation of these temperatures, look at that word again, circulation. These circulating waters and their temperatures help to warm areas that would not usually receive warmer or cooler temperatures. We want to remember, and this is super important, we talked about this with land breeze and sea breeze, and it's just as important when we're talking about ocean currents. Water regulates or controls the temperatures of the lands it flows near. So what do I mean by that? 1 second, please. You should be writing this down. Another word for regulates is controls. So what do I mean by it regulates or controls the temperatures of the lands it flows near? Well, look at this Gulf Stream current here in this first example. That Gulf Stream current carries warm water up. It's coming from Florida, from Cuba, from the Bahamas, and it flows north to Iceland, to the British Isles, to certain parts of Europe. These places are very cold. They're in the polar region. So what happens here is that warm water is going to carry warmer temperatures to these places that are usually colder. That's a good thing. That helps the temperature to not be too cold. If that Gulf Stream current didn't flow to these places that are very cold, they would be solid ice. So that temperature, that warm water, helps to regulate, control, keep at a steady level the temperatures of these areas that are usually very, very, very cold. In example 2, we see how the California current that carries colder water down from the polar region, it helps to cool off, to regulate, to control the temperatures of places that will usually be very, very, very warm, like Baja, Mexico, certain parts of the California coast, okay, and all the way down to certain parts of the Mexican coastline. It's important for us to understand here that without this current being here, these waters would become superheated. But because that California current carries cool water down from the polar region, it helps to stabilize, to control, to regulate the temperature of that water and the land, the temperature of the land that's near that water. Take some time to finish this up. Miss Neville's going on in 2 minutes.
Miss Neville,
Yes?
do we have to draw those 2 pictures?
No, ma'am. Good question. So let's talk about the assignments that you're going to need to complete today using these new notes.